Hi, today I would like to show you what I found last Saturday on a flea market and what I couldn't resist to buy. It is an old Commodore 64 microcomputer. It is the German version of this microcomputer because I bought it in Germany, and I was very surprised what I actually found in the box, because it was not complete. This is the original package of this Commodore, but in the package I found only the computer without any power supply or cables, the sole computer only. First, as I unboxed the PC, I found this device inside, and the man who sold this to me and shows me it still works, and if it's damaged I should bring it back, but I don't really like to bother anyhow because I paid only €6 for this device. He wanted me to pay about 15, but I was not consent, and so I already said thank you, sir. Maybe someone else will buy this Commodore from you for the price you accept. And in this moment he shouted after me, wait, come back, give me the €6 and take this PC or the Commodore. Well, to my surprise, it seems like it has never been opened, the case of the computer. The computer is right now, considering the first exemplars of this Commodore came to the market in 1982, is in a surprisingly good condition, and it seems to me that it wasn't opened yet. But when I had a closer look at the 3 screws which close the case, the screw 1, 2 and 3, I felt that the screws are not torqued very tight, so I'm afraid somebody already opened this PC or this Commodore for what reason, however reason. Here you see the original label. On this side we have the power connector, the on-off switch, and the 2 input-output ports for joystick or for mouse or for pedals. The inputs have the capability of controlling a potentiometer, which is then digitized inside our input-output chip, which we will have a look at when I put this Commodore 64 apart. What you can see here is the on-off switch, and as I was touching this for the first time and trying to test switch, I don't have the power supply for this, so I won't be able to test this today, but we will have anyway a look at the motherboard. But it comes to my view that the board inside is somehow not screwed down, so the whole panel moves inside, which is bad, I think. You will see in a minute what do we have inside, if all the chips are still there where they should be, or if there were some repairs before or whatever. But before we come to this, we just have a look around the Commodore. So this side you already saw. Now we go to the back, we have here an expansion slot. You are able to slide your cartridges inside, or also some sort of extension cards like the Power Action or Power Game Pro, and with this module you were able to debug, modify and hack any program inside the memory of this Commodore. Then we have here kind of adjustable capacitor that was to fine-tune the output of the video, the composite video output, to the television set, which is what was thought for. Going on, we do have another two ports. Just have a look here, and these connectors, like they were popular those days, these round connectors with all the pins on the edge of the connector. Of course we don't have those connectors anymore. Those are just big connectors from those times, and one of those was the serial connector RS232, and another one was supposed to be the disk drive connector. And in the back of the Commodore we have another two slots, also for expansion cartridges. One of those was for the tape. You had the choice to buy a tape to store your data on and your programs, and to buy ready games on the tape, because the disk drive those days was very expensive and cost almost the same money as the Commodore C64 itself. So the first choice for computing was to buy a dataset, and you can store your data and your programs on those datasets on a compact cassette. Which one is which, I don't know. We don't have any descriptions on the back. I think the descriptions, which port is what, came later on later Commodores. This computer holds still a record. It was sold above 12 million pieces, and it was produced over 10 years, I think from 1982 to 1994, something like that. And then of course they quit the production because there were more powerful computers on the market, and people moved from 8-bit computers to 16 or 32-bit computers. Okay, enough spoken. You see all the keys are still there. They are in one good condition. This computer doesn't seem that it has been used extensively, because the keys don't have any, you know, if you use a keyboard, then with the time you become some traces of your usement and shiny keys or anything like that, but this Commodore doesn't have any. So maybe it goes broken, and the owner puts it back in the box and store it in the cellar. He wasn't affected by computing, maybe apart from playing some games, not really affected in computing. Okay, let us take this Commodore apart. I just need a towel. So I don't scratch the surface of the PC or of my desk. So okay, let's unscrew this puppy and see what we have inside. So the screws here, the 3 screws are very loose. So someone has opened the case already. Okay, and we need to turn the Commodore around. This is the old case from the Commodore. It has in his career, it made in his career some changes, some improvements. So this is the old case. The newer case does look a little bit prettier, is flatter, and the motherboard inside has also another revision. And we need to slightly put this front up, then turn it a little bit around, and we do have a keyboard which is underneath the top case and which is connected to the main board via a flat band cable. No, that's not really this cable I thought it is. It has many wires and also single wires which are connected together somehow. Okay, and here we have a connector. Let me disconnect this. Okay, and we have another connector for the LED status LED here in the back. Can you see this one? It's here. Okay, so we disconnected now the keyboard from the main board. Okay, it seems okay so far. We still have a sticker in the back which holds all the individual cables which are going to the keyboard PCB. Here is the status LED, the connector. Can have a closer look. And what also is here, and I don't know what the purpose of this one is. Oh yes, okay, listen. This part here is a real switch. So you have your caps lock. Actually it is called shift lock. See, this is a real on-off switch. So you can permanently switch your shift lock and then you can reach the double or triple function from this keyboard here. I don't know exactly what the shift lock activates. Okay, let us put this apart. Okay, here the keys one more time, and the famous function keys. 4, but with pressed shift you activate the double function, and actually those are 8 switches. Okay, let us put this apart. The keyboard, the PCB inside is protected by a cardboard shield. It is covered with aluminium foil, and this solution is cheaper and doesn't weight as much as a real shielding, and obviously it was sufficient to put just this simple shielding solution to this board. Here's a latch. The latch is put on the frame to the expansion slot, to the cartridge slot, and we can simply push it back and up, and we are free to open the board. Now let us see What does it find? Okay, we already found the bug, people. Just have a look here. Do you see it? That's the computer bug. Okay, I'm kidding. But it's not very surprising to find some dead insects inside such an old computer. Yes, okay. That's what we have. Let us discuss a little bit what the main components are. But first I get rid of the dead spider, okay? Because it's a little bit disgusting. Looks like from the Alien movie. You see that spider. I wonder if you can win DNA from this spider and clone it. And here's also his web. Do you see this? This is the web the spider made before it died. Okay, let's get rid of it too. And now we have exposed the main PCB from the Commodore 64. And in a minute we are going to discuss all the parts on this particular board. Okay, let us start. Oh, I see here something what annoys me. The screws that are normally holding the board down to the plastic bottom plastic case, they are all loose and put in a different angle to the plastic threads underneath. So someone has already put that board completely out from the case. And what we see here in this corner, you can see it now, but here in this corner we do have the problem which caused the whole board to move inside the case, because the screws aren't fastened enough. So let me unscrew this board totally and have a look what do we find underneath. Maybe more dead spiders, or even worse. We will see. 1, 2, 3, 4. The screw has another thread. It's not a plastic thread. There's a metal thread on this one screw. Okay. 5. 6. 7 and 8. Now let's see if we can remove this board from the case. Yes, we can. Can we? Yes. Okay, and what do we find at the back? Okay, let us discuss it in detail. I put the back aside. We don't need it anymore here. And you can see the cardboard shielding is glued to the bottom of the case. Maybe some glue straps are underneath, and they hold the whole shielding in place. Unfortunately, we do not have another spiders or anything like that. Sorry if you waited for some other spiders. Okay, and here we have the main board from the Commodore 64. First we start with the imprints on this board. Can you see this one? Fab number 22046 revision A, assembly number 250407. Then another imprint, KU-14194 HB. I read on the case from this Commodore that it was made in Germany, so there was a Germany set for the Commodores. They were produced for the German or for the European market. And this is one of the earlier Commodore 64 computers. This imprint proves that it was made. Wait a second. It does prove nothing. This probably just a standard imprint on every Commodore 64 board. 1983 Commodore Intel, not Intel, but it's spelled similar. Intel Commodore 64, assembly number 250407, artwork number 251137. Got it? Okay, this is the right orientation of this board to easily read the imprints on the ICs here everywhere. But let us start this way, because we will start with the power supply. So externally you connect the power supply, and the power supply contains of two voltages. One of these voltages is an alternate current, just this secondary winding from a transformer is put right into this connector, and it has also another voltage which is stabilized from the already in the external power supply. We have on this bottom label the voltage, the right the imprint on the imprint, the right voltages. Also, this is 5 volts stabilized and 9 volts alternate, DC, AC. Both together take about 15 watts from the power supply. Okay. The shield is a little bit dusty. Probably can see this, but there's dust. But not so bad as I thought it could be. Okay, then let us go on. Let us talk a little bit about this Commodore. So the Commodore is built around the 6510 microprocessor, and this is this guy here in the middle. It is an 8-bit microprocessor made by the company MOS. and Commodore bought the MOS company with all their knowledge. And the 6510 MOS microprocessor was those time very inexpensive, and the predecessor or the designers of this processor worked at Motorola, and they were involved in the construction and design of the 6800 microprocessor. So there were some legal issues about patent rights and solutions, and a little bit of the 68,000 Motorola microprocessor design is inside this MOS 6810. 6810, this is a version of the 6802 processor with the inclusion of additional logic which is controlling the switching of the memory banks, because we do have the processor is connected with external RAM in size of 64 kilobits, no, excuse me, 64 kilobytes, but it can also address external ROM with the kernel and with the basic interpreter, and also we do have a char character set for the graphic display. They both are either in those both ROM chips. What else do we have? We have here a shielding. Oh, I see some fingerprints. That was obviously the previous owner playing with that board. I still don't know if the board works. Hopefully yes, but he probably has a reason to put it apart. Also, those pins here connecting the LED seem to be bent this way, or they had been bent this way on purpose. So here we have the microprocessor, then the RAM memory. This is the DRAM, dynamic RAM. Every memory cell in those RAMs consists of a condensator, of a capacitor, and holds a logical 0 or 1 for a certain amount of time. It can hold the charge, it is unable to hold the charge forever, so it needs to be refreshed in a periodical manner. The refreshing of the RAM is probably realized by one of the external chips. So the MOS external chips are already implemented in the microprocessor. I don't know exactly. But we have some other chips which made this Commodore 64 model famous and so popular. And this is the graphic chip and the sound chip. Looking at the traces, we can maybe figure out which is which. Okay, one of these connectors, this is a sound connector. So you can connect to high quality, hi-fi audio equipment, if I'm not mistaken. These two guys in the end of this board are their input-output controllers. One of them obviously also controls the keyboard because it is directly connected to the keyboard connector. All the capacitors you can see here, those are blocking capacitors, and they are connected directly to the IC power and ground. The purpose of those capacitors is to prevent any fluctuations in the power supply voltages. Let us identify the oscillator, the quartz oscillator, which is driving the microprocessor and all the boost timings. It needs to be on the top because this is one-sided board. This is not an SMD mounted board. All the components are through hole components, and on the back of this PCB you can see them and I see someone has tried to repair something because I see fresh residues, not fresh but not originally existing solder joints. This tree has been resoldered, also the connectors or hand soldered. Maybe it is a factory soldering. Normally you solder this sort of things on a machine, reflow machine. The board is transported over a wave of solder and soldered in few seconds. All the components on this board are soldered to the board. The green color you see here is the solder resist. So the solder can catch the traces all around the board because the traces are protected by this green paint. There's a special kind of paint which prevents hot 300 degrees Celsius hot solder, and everywhere where a soldering point should appear there is a free solder resist free place. So this one connector, all the connectors on this side, this transistor here and this part here, also those two parts, every of those parts, judging on the solder joints, are hand soldered or were been soldered by hand. Have a look. Okay, see the difference? This is machine soldering joints, and those joints were made by hand. You see the flux residue on the solder joints. Oh, okay. I see here it was not necessary to unscrew this one screw with a special metal thread, because it just holds, it is not connected to the case, it just holds this metal blend around the power connector and the joystick in and outputs. So let us, by the way, screw that back down. Here we go. Okay, I tightened them. Okay, let us jump to the other side, because we have it here. It happens that we turn the board around and we do have some powering stuff. A filter, which seems to be a filter behind the power switch. Then it goes to this fuse, and this fuse seems to be okay. And after the fuse we do have a rectifier bridge, which turns the alternate current into DC. Then we have some filter capacitors. They all seem to be alright. Okay. Then we have another few diodes around this power subsystem. Let us have a close up at this fuse. Okay, here you go. And after the rectification and after the filtering with those capacitors, we do have some power converters which produce stabilized voltages needed by the chips and by the ICs. Here we have the 7805 voltage regulator. The complete name is probably from Motorola, if I correctly identify the logo on this power regulator. And this is the AN7805. This is because of the dust, excuse me. And here we do have a 12 volt regulator. This is the AN7812, 5 volts and 12 volts, made of the 9 volt DC AC voltage. Okay, let us go. So this was the power subsystem, and what we have here in this can is the video subsystem. I will try to open this can so we can have a look inside. And it was extensively in use, as you can judge on the traces on the can. It is somehow rusted, because when you put your fingerprint at such kind of metal sheets, the acids start to react when it is not protected by any covering, any paint or transparent paint. So let us, oh, I can't remove this top cover because it is soldered to one of the components inside. So we need to leave it this way, but we will try to open this can instead. So here it's all the components that are responsible for producing of the TV pictures. Okay. And how about this can? Can we remove it? It already seems to be a little bit lifted on one side. Here this corner is a little bit lifted already. So we try to go on and remove it completely. Oh, this is not the right kind of tool I need now. Let me bring some screwdriver. This screwdriver is better for removing the top can. Yes. Here we go. Oh, actually here's a heatsink. This whole top is a heatsink for this chip. So this probably is the video controller or the video interface device in this revision. Here we have a copper or metal latch which is connected to the top, and on the bottom with some thermal paste directly to the chip. Maybe this chip has failed because someone played with this shielding and he didn't know that the shielding is also the heatsink. So the chip overheated and caused this Commodore 64 to fail. So let's have a look what's underneath the shield. For all of you who is interested in such things. So it's the video chip. It was a very good video chip for in those times. It was better than anything else on the market. It was capable of 16 colors of sprite, collision detection among the sprites. Everything was done in hardware. And it was a very good chip for game programmers. It used some tricks to put the most out of the limited video memory this Commodore 64 had. I think it can directly address about 8 kilobytes of memory, which is the video memory. So here's the main chip. We do have some passives around. We do have a quartz oscillator inside the case, but this is not the quartz oscillator I was looking for. Here we have an imprint of 17.734 megahertz probably. Toyo branded. Okay, enough. It's enough looking. So I'm still looking for the quartz oscillator which is driving the main processor. I still didn't find it. I oversee it. Where can it be? It should be normally somewhere near the microprocessor, so it has the shortest path to it. but I can't detect the quartz on this board. The filter capacitors are all ceramic and all of the same type and capacitance. 10-4Z. 10-4 is probably stands for 10 and 4 is the multiplier, so that probably are all 10 or 100 nanofarads capacitors. Every chip has its own filtering or decoupling capacitor. Maybe it is the oscillator I'm looking for, the 1 MHz, because this Commodore 64 is clocked with about 1 MHz oscillator. It can run faster because it would overheat and produce errors, and that would cause the microprocessor to completely damage. Maybe this 1 MHz is generated from this quartz, so maybe the frequency here is reduced 18 times and feed into the microprocessor. This is the explanation I can give you now for the part I'm looking for, and which probably does exist and at all. I am not a Commodore 64 expert, but we identified this chip as the video interface controller. So this is the microprocessor. Some of those parts which are socketed is the ROM, or probably we do have 2 ROM ICs. These 2 guys we identified as the input-output controllers, which one of those controls the keyboard, another one probably controls those joystick or gamepads connectors. We can follow the traces. They go all the way around the board and vanish somewhere here. So it could be that they are connected on the back, because this is a double-sided main board. It has traces on the top and on the back. Yeah, it seems so. Those interconnections lead the traces further to those chips. Okay, memory modules and some glue logic around them. This is standard TTL stuff. For example, this one is the DM74LS 139N. So some bus driver logic, low voltage or low power. I need to look the descriptions up to tell you exactly what those chips do. But okay, that's all I can do now. Maybe I can build power supply for this Commodore and test it actually under voltage, or maybe I can connect individual voltages and measure if the power sub system is still working, if it provides the voltages the chips need to work. But for now I would say thank you for watching. I hope it was interesting for you, and as a special bonus I'm showing you the board one more time. And the back. Okay, thank you for watching. Right now I will just put everything together, put everything back together and save it for another test with power supply. I also will need the cables to connect the computer to the TV. It is in a surprisingly good condition. When it was produced in 1983, like the label here suggests, then right now it is 30 years old. I wonder if it still works. I would like to find this out, but I don't have the cables, I don't have the power supply, and this will take a little bit time to make some to replace the original, which wasn't in the box, and I'm afraid it's damaged, judging by the hand soldered joints and the opened can. Someone obviously already checked or was looking for the failure inside this board. Maybe just one of the power regulators is damaged, so it will be easy to replace, but if it's damaged this way that it involves the chips around them, then also the chips can have a failure. What I could do right now is to test some power rays with the ohm meter to tell what resistance exists on the rays, and I could look for a short. Yeah, that's not a bad idea. So here's my ohm meter. I will measure the resistance of the power traces, putting it that way. placing the voltmeter so you can see the readings. I'm holding one of those terminals of the ohm meter to the ground, or maybe I can consistent put it to the case. The cans are grounded, and now I will measure some resistance voltage between the power rails and the ground. The ohm meter is set to the 200 kilo ohm range, and now I am measuring the power regulator, the 5 volt power regulator, pin 1 to 3. Pin 1 shows about 10 ohms and is rising. That does mean that the capacitors are charging. So but that is not the short I'm looking for, I'm checking for. Pin 2 does show 0, so the pin 2 is probably ground. It must be ground. And the pin 3 shows a very low resistance. I'm now changing the range to 2 kilo ohms and measure again at pin 3, and it shows a resistance of about 570 ohms. So this is a little bit low, but also not too scary. So this is not, obviously not a really short 500 ohms. Okay, I'm hoping by measuring the resistance I'm not damaging any on those chips, because those are CMOS chips, and they are very sensitive to any voltage applied in the wrong way, and those days they probably weren't protected like they are now. So now I'm measuring the 12 volt power regulator, again pin 1. I'm starting with the pin 1 of this regulator, and I'm